guest speaker with us for this plenary session. I request the keynote speaker of today's plenary session, Dr. Neha Hebalkar, scientist, Center for Nano Materials. I request you come on to the dais, ma'am. And I also request Professor Madhukar to come on to the dais and chair the session. Yes. So, Madam is going to speak on nanotechnology, bridging disciplines, shaping the future. Thank you for accepting an invitation to give a keynote address on this session, Madam. And I welcome you once again. So, I request Dr. Madhukar Garu to hand over bouquet to Madam and also introduce the Madam for this session.
I think Madam should.
Welcome back. You are okay, thank you so much. Nice. That's already short.
Yeah.
No need to talk to. Yeah, I can send it.
Good morning. It is my honor and privilege to introduce a very eminent scientist from ARCI, the central government organization. They develop a lot of materials for various defense applications. They're not supposed to be told outside. So some sort of classified projects rather. So on the academic side, I knew Dr. Neha Madam for the last 10 years. I'm from Osmania. We have very close association with ARCI. So in terms of developing different materials. So to introduce Neha Madam is very difficult because she has a lot of achievements, credentials in her bag. So I'll just make it very simple. Madam is a scientist working more than 25 years in R&D using for the nanoscience and technology. She did her PhD from University of Pune. I know she has done masters and bachelors from Shivaji University.
Yes.
And both universities are very eminent, like Osmania.
Like Osmania. Certainly. Of course.
In Maharashtra state. Madam she's a fellow in Maharashtra Academy of Sciences, and she developed a lot of materials. I knew a few paper publications. She developed some fabric of antibacterial, antifungal, things like that. They are all patented. She has published more than 70 publications of international repute. She has extensive experience of product development, full life cycle, starting from designing up to the patent and commercialization of this. The beauty of the ARCI is that whatever the material you develop, it will be patented and also commercialized. So it goes to the society. That's what the theme of the conference. So whatever your scientific achievements should go to the society. So they are the people, rightly they are doing that job. Madam has mentored more than 70 MTech and MSc students. She frequently organizes many conferences. She delivers a lot of talks, sensation talks to the school students also. With this small brief, I welcome Madam to make her presentation. Thank you.
Thank you. Sir, I wanted to tell very significantly that apart from his work in the research, is also into women interested in women research. Please also that specifically.
So beyond her scientific contributions, Madam is passionate about promoting women in STEM and women's safety at workplace.
She is into women harassment. Women harassment, sexual harassment. Thank you, Madhukar sir, for such a kind introduction. Good morning to all. Respected PC Chakrapani Garu, Professor Chakrapani Garu, Madam Professor Pushpa Garu, all dignitaries, faculty of this university, all participants present in this seminar, and all dear students, my heartfelt namaskar to all of you. So I'm really glad to know that this is the topic of this seminar. This is my everyday experience that interdisciplinary method of work is so essential if you want to really solve any problem we are facing through our research. No single person or discipline, any subject, not possible to solve a problem. It is very similar to if we want to be healthy, we have to eat all nutrients. Just by eating salad or only protein or only carbohydrate, we cannot be healthy. Or another example is if I have a headache, like even doctor treats our health issues, if they treat holistically, considering what may be the root cause of the problem, then only the problem will be cured. Otherwise, it will surface again and again. So similarly, in research, we have to be holistic in approach to solve any problem. Then only we get a sustainable solution. For example, we are facing a problem of energy. So we have to think if we are giving some solution now for present problem, is it going to create new problem for the future? It should not happen. So sustainability is the very important keyword right now in all scientific branches, whatever we are doing, so that we are giving a problem which will not create another problem because of that, and we will sustain as a life on the earth. So it's very, very important topic, madam, for you have chosen it for your seminar. I really appreciate and congratulate you for that. Thank you. You know, when I thought of having this talk and interaction with you all, I really remembered Acharya Jagdish Chandra Bose, who was a real polymath. Polymath means he was well known and very expert in many subjects. It was a time of 1858 to 1937, his lifespan, and he was a physicist. He is known as a father of radio and wireless communication, hardcore physicist, botanist. His interesting research is similar. He studied how the external stimuli affect the plant growth and how it is comparable from animals and plants. How the animals and plants respond to the external stimuli such as light, electricity, sound, and then he found that there is a lot of similarity, there is a comparability. So a lot of botany and biophysics was there. He introduced many indigenous, very sensitive equipment for radio detection, radio wave detection, as well as this stimuli, whatever he was studying for plants and animals. Very precise instruments he developed. He was a science fiction writer also, and he founded a very famous Bose Institute, which was the first institute in Asia for interdisciplinary research. So I I was remembering him for like who is the best example for us. How if there is a holistic approach, if we don't keep any boundaries in our mind, how uh, the new concepts, theories, philosophies evolve and they become a long lasting. So my tribute to Acharya Jagdish Chandra Bose on this day. Now, I'm going to talk about nanotechnology. That's my core subject, so I will precisely talk about that. And in general, if you see, materials are the basis for every problem solving and any advancement in the life. If you take any discovery, technology, and try to find which has no connection with the materials, finally it will boil down to materials only. Even if you take AI, supercomputing, finally to execute whatever it has to do, there is a material behind it. Okay, so that is why probably we call this as a materialistic world. Okay, and I thought a lot about it and found so relevant that why we call our life everything so materialistic. Even spirituality, if we want to develop or think about it, it is our brain to process it. Finally, brain is also some material, right? So I feel it's extremely important aspect of our life to study the materials. Now, there are materials everywhere. We know that in home communication, like a lot of research has gone. Today, whatever we are doing today, whatever we are wearing, whatever we are using, someone has done some research earlier, and that is why we are able to have this comfortable life. It's 40 plus temperature outside. We are comfortable here with air conditioner. So we are not aware ki how much science has gone behind in our life. And it is, some people are there who say that technologies are, disturbing the balance of life and all like that. But being a researcher, I feel that nothing is bad. Only how we use it is important. So there is a whole lot of research has gone for all materials which we use for health, home, entertainment, communication, transport, apparel, outfits, everything, right? You agree with me? Yes. Yes or no? Yes. Yeah, please interact so that I feel energetic. I am not a teacher by my profession, so I need a little bit encouragement from audience. We know that so much evolution we have gone through from Stone Age till today. I think our generation, probably every generation may have thought, but we strongly feel that we have seen so many changes in their life. Just take communication part of it. Like I can see, from the uh, calls made through telephone exchange booked before we want to do any call to that the mobile phone which are so smart, and I think the best friend is our mobile phone nowadays. We can't live without it, and we can live without anything else. We don't need money purse in our pocket. We just need a mobile. I think we can survive anywhere in this world. So this is the transformation, and it is because of materials. In case of nanotechnology, when I was a student, it was late 90s, you can say that time. We were studying different materials like quantum dots, other nanoparticles, carbon nanotubes, all like that, and how the properties and morphology, size, everything is correlated. So, kind of study was going on. A lot of publications were coming up, but then now time has come where we are using all these materials. The science is matured, and we are actually using and the products out of that. We are not aware where all we are using nanotechnology. I think I'll come up in my talk how we are using and we are still not aware about it. So the complexity of nanomaterials is increasing.
right from single particles or anything. Right now, there are so many self-assemblies, composites, and their structures which we are using it. So there is a lot of evolution happens with time. So in case of material science research, uh, we start with the basic concept, right? I want to develop some material which will produce hydrogen, for example, in a very efficient way. So, which is that material which will convert, like use solar light, everything? Like this is a concept. So now the new aspects of research are first, with the available data in the literature, you do the simulations and predictions. There, the artificial intelligence and machine learning is becoming a unavoidable or most required part of the research. So you do some predictions because there is a huge amount of knowledge available, information available. Now arrive at a particular solution, you can't do all trials and errors, and your knowledge, it is impossible to do it in the short time. So we have to introduce this part in our research, and it is going to be a mandatory part eventually. Now then we go for experiments based on the predictions. Then we do optimizations where all the branches of science will play role. Chemistry, physics, biology, maths. These are the basic sciences. Then we go for, after doing that, we discover if this is the best material, or these are the three best materials out of which I can go further. Once material is discovered, then we go for product. Like I have particles, nanoparticles or nanomaterial, but we can't use it as it is. We have to pack it or form a film or make a composite, something. So we have to convert that material into product. And then in that, some engineering gets involved. You need sophisticated equipment or some equipment, simple equipment to do the product development. Now, once it is developed, we have to optimize for the best performance. Now the product is formed. Now we have to integrate into device. Okay. So now I have one solar cell. But to generate huge energy, I need to integrate many solar cells so that I have big power with me. Now integration again is involves engineering. So I'm just giving one example. Engineering, like chemical, electrical, electronic, everything is necessary for overall to make the final product. So this is a journey one person cannot do, one researcher. It should be a team or a collaboration between all of us so that we achieve the final goal. Now, we know this periodic table. It has so many elements. To arrive at a particular solution, how do I do mix and match, and what material I should make it? It's a really a tough to find a final solution. So you must be hearing every day in our all media, all types of media, these green hydrogen, then silicon, all solar based are right now maximum usages because of the silicon solar cells. Lithium ion batteries, a vast and research is going on throughout the world. Lithium is getting replaced by sodium, iron, and some other elements also. And the biggest problem of today is CO2, right? CO2 is not bad. It is essential for our life. Anything excess is toxic. So probably that is what we call it as the excess CO2. So we are working on how to reduce it from our atmosphere. We will talk about it. So these are the elements which are right now every day. Even a small common people know about it, what is happening, why these are so important. Okay, let me tell you some briefs where nanotechnology is helping to solve the problems or crisis which we are facing. First, I will take energy. Now, we know that energy efficiency is the most important aspect in all industries. It's a mandatory part of it now. What is energy efficiency? Is nothing but energy production and energy consumption. There should be a balance between it. Now, production means we are now short of our fossil fuels. So we have to find some new renewable energy sources, safer atomic energy. You may have heard about fusion and fusion reactions for the energy generators. Then for all that, we need efficient energy generating equipment also. It is not only materials, but equipment also equally, they should be efficient about it. Then aspect comes of energy management. So balancing the demand and supply. How do we achieve that? So that is called as energy management. And then improving the efficiencies of processes, heat transfer, transmission, recovery, everything is also equally important. I have 10,000 rupees in my pocket. I know that much fuel if we have it. Till we get the final good solution, I need to save my whatever is in my pocket. So that's also equally important strategy. So energy generation, energy saving, energy management, everything becomes a part of energy efficiency. We know about lithium and battery. I just for maybe young students, is it audible or visible? It's not audible, but Yashwant, is it possible or that we will skip it? No problem.
I just asked the technical question.
No, there.
It's okay. We will go ahead because we have a limited time. So in any battery, we know that anode, cathode, electrolyte, and separator. These are the most essential parts of it. And we are all using lithium and battery, you know that, right? Are we using lithium and battery in our everyday life? Where? You're using, it's there in your pockets.
Your dearest.
In the mobile phones, we are using it. So batteries are of also different, even this laptop has a lithium-ion battery. So there are different types of batteries for different purposes, okay? So we can't use the same chemistry, same materials, same design for every application. There is a vast research. The lithium-ion battery can go for a truck to drive as well as for a small toy to run. Like it can be anything, drones, then two-wheelers, like you name it. There is a different construction of lithium-ion battery and it is different for different demographies. The one which works in cold countries doesn't work in India. So there is a lot of research, not only in the materials, but its construction, which is, no, we have to make it a India tailor make for it. Okay. Now, how the nano is important in lithium-ion batteries. We know that I would have shown this video, how the charging and discharging happens. Like from cathode, it is generally some lithium carbonate or something material is there used as a cathode. Lithium goes from the cathode to anode and the electron is passed. That is called as charging. When the lithium goes from anode to cathode, it becomes discharging. So now lithium ion has to diffuse into the material, whether it is anode or cathode. If the particle is very big, the diffusion length becomes very big. So the efficiency goes down. If you reduce the particle size, the diffusion length also becomes small. You can see here how, and that's how it becomes, nano becomes important here. So all the materials which are used are actually nanostructured materials. But you know who are studying nanomaterials, if you reduce the size, the electrical conductivity goes down. Okay, the metals start behaving like semiconductors. So I'm not covering how the nano changes the properties in this lecture, but because of size, there is a lot of difference in the properties from the bulk materials to nanomaterials. So metals start behaving like semiconductors. Semiconductors will start behaving like insulators, for example. So now to achieve that, no, to increase the thermal conductivity, we have to do the coating of the conducting carbon. So this is how the problems are solved. Okay. First make nano, okay, new problem comes. Now how to solve that? Again, there is a nano solution to another. That's how the nano is so important in lithium and batteries. So in ARCI, from where I belong to, it's a DST's Autonomous R&D Lab in Balapur. Please go through our website. We have a lot of interesting tech transfers. We have done it. If you want, you can go through our website. Now, this is the lithium iron phosphate. Is the most important material used in lithium ion batteries. And the first plant of this pilot plant and now manufacturing plant of this material out of my organization's technology, I'm not part of that group, but they are my colleagues, is coming up in India. We are becoming Atmanirbhar in that perspective for our country. Now, I'm just giving you a glimpse, okay? Whatever I'm telling is only some example about it, about nanotechnology. Now, in renewable energy, like whatever you take, whether it is photovoltaics or solar thermal or geothermal, wind, tidal, everywhere there is a role of nanomaterials in some way. Now, you know about silicon solar cells, I'm not talking about it right now, but there are other types of solar cells. One is dye-sensitized solar cells, where the dye molecule, which is generally an organic molecule, absorbs the solar light and which will get converted into the electricity. Now, these organic molecules are very unstable. Like after exposure of sunlight for few days or few months, their performance goes on decreasing. So you need replacement. And as we were talking, Dr. Madhuri, we can use quantum dots here, which will increase the performance of the dye-sensitized solar cells. If you visit any TV showroom, you will find QLEDs, a product in the market. Some of you may be using it also. Like it is amazing clarity and the experience, what we get it. That Q is nothing but quantum dot. So quantum dots are now in our life. This is how is one of the example. This is the best example. I can say that most successful in common man's life. I'm not going to explain its physics. We'll go ahead. Now we will come to the energy conservation. Mostly, I'm giving you one example of power generation plant. Okay. Now, what is happening in power generation plant? There is a steam produced in boiler. That steam is passed to the turbines and that rotates and forms the electricity. Now, the steam is passing from the boiler to turbine. The efficiency, like there should not be any loss of temperature and pressure, then only the energy generation is very efficient. Okay, to avoid that loss, some thermal insulation is used. Now, there is a lot of problem. So people are finding new materials. So what is the problem? It will absorb moisture. Water has a higher thermal conductivity. So it will have a less thermal insulation performance. It becomes heavy so that there is a sagging happens there. And there is a lot of, because these are bigger pipelines and very thick, high, heavy diameter pipelines. So a lot of material is required. It's very cost expensive if something goes wrong there to replace. So we are coming up with a new material, which is the most globally comparing material, which is based on silica aerogel. Its aerogel is extremely porous, 95% porous and only 5% solid in that. It's a nano-porous material, which is the best thermal insulator in the world, known materials. So we are coming with a product which has which has passed all the requirements of thermal insulation performance. We are competing with the American, Chinese, and Korean product which is there in the market and bringing up our own Indian technology. This product is getting commercialized soon. So this is from my laboratory. I'm part of aerogel. Is my core area of research since several years. Now another product we all agree to it, I hope. When we have a temperature 40 outside, inside we have done salt measurements in our lab. The inside ambient temperature, if there is no other insulation or air conditioner is not there, then it can be 38 degrees. Now we are setting up the AC temperature at least 25, right? So there is a drop of 13 degrees to be achieved by the air conditioner, right? It's a huge energy required for that. And this is only our home or office room is okay. But we have so many big multiplexes, theaters, no? Big offices. So much energy is being used. So can we save something out of it? So every 1 degree we set lower, no, or one temperature, it saves about 3 to 4% energy. Of course, there are some assumptions behind that, that air conditioner should be 5-star and all like that. Okay, so there are some conditions behind these numbers. So we have done all that measurements and we are coming with a new tile, a kind of a wallpaper or tile, which will you have to just fix on the wall, which are exposed to the sunlight, and it will reduce the temperature by 5 degrees. So 5 degrees means of minimum 3% saving if we do, still we will get some 15% less energy bills. Is that acceptable? I just want to know opinion about, because we are developing in lab. I want to opinion of all of you. Is it really useful? Are you sure we should go ahead or it's not so encouraging? We should go ahead or not in this research? Okay, so this product we are coming up, a prototype has been developed and it has shown that 5 degrees, or it's actually more than 5, but I think we will eventually probably will get 5 degrees. Okay, next, let's go for a global warming crisis, right? We are all hearing that the Earth's temperature is increasing. Now, why it is increasing? Because of CO2. How? Because of CO2. Now, generally, when the sunlight is fallen on the Earth's surface, the most of the light gets reflected. And the maintenance of the temperature is balanced. But now what is happening is so much excess CO2 is in the atmosphere, which is not allowing the heat to go up. It is absorbing the heat. And that's how the temperature of Earth is increasing. And 1 degree increase, we feel what is 1 degree, but no. There is a lot of impact on all kinds of lives on the Earth because of that even 1 degree. So if you see this graph, if we follow all the treaties which all countries have signed, if that everybody follows and achieved, then by 2050 we will be carbon neutral. But so far today, there is not so decline in the CO2. So what is happening? We are working on several materials which will capture CO2 and convert them into some useful product. It can be some organic molecule, it can be ethanol, methanol, some fuel, so that we are reducing the CO2 from the and making use of it. So many zeolites, graphene, carbon nanotubes, aerogels, like either it in the form of capturing CO2 or as a catalyst to convert it into something. So this is a very hot topic right now, where whole world is researching to find the best solution. Still, the best has not yet come. There is a scope for all of you to think of this subject as your research topic. We know in COVID how many ways we have applied this multidisciplinary approach of solving the problem, whether it is mitigating the spread, like testing kits, medicines, devices, monitoring devices, sanitization, surveillance, and whatnot. Then prevention and then treatment. Everywhere, different sciences have come part and taken part, and it was so efficiently done by our country, and we are proud of it, right? So the same nanomaterial, we used it for detecting quickly the COVID-19, like finding the antibody for it. Then we were working on disinfectants, lot of surfaces to avoid any infection spread. So using nano silver, many surfaces like for textiles, especially the medical textile, was developed. Masks, which will kill the virus and bacteria while we are breathing. All this was developed. Of course, before also this was there, but this was specifically used to mitigate the problem. Then self-cleaning of surfaces, fabrics, packaging material was also become become surfaced. As we have to do some bring some products in the market so that we can stop the spread of the material. So where either the lotus effect, very similar to lotus leaves, how it cleans the surface by the water rolls over on the surface and gets dirt along with it. So that is called as lotus effect. It is again because of the nanostructure. So if we make some nanostructuring on the surface, we can get the same lotus effect on the surface, or by using the photocatalytic effect using nano. So this is one of my laboratory's outcome. I just want to share with you. I'll just say that suppose we have a denim jean pant and we wear it, which will give your breath fresh, feel fresh. It will protect from UV, save water, save detergent, save electricity, save time and effort, and save environment. Everything will happen only you have to wear our denim jean pant. I think it will be it is most welcomed. And that is because of the photocatalytic effect. It's not at all a magic. It is nanotechnology. So this nano TiO2 will degrade the organic pollutants in presence of sunlight and small moisture, and will degrade all the organic content. This product, several products in the very well-known brands are there in the market. How much? Please give me a time.
10 minutes.
10 minutes. Okay. So in medicine, you know that this is a new concept, which is a controlled or targeted drug delivery. What does it mean? If I have some problem, fever, headache, stomach ache, I take a medicine through mouth. It will go to the blood. It will go to all my body, and it will also go to the affected area. Okay. So why there are side effects because of the medicines? Because they are going where they are not required to go. Okay. So if we are targeting our medicine only where it is required, the side effects will be minimal. Okay. Especially the treatments of cancers, where the chemotherapy is really more so harmful to the body as harmful as the cancer. So if I say you that I have a polymeric capsule which has a magnetic nanoparticles on that, okay, and the capsule contains the drug, which is probably, for example, for chemotherapy. Now, it is injected in the blood vessel somewhere, IV, and you apply magnetic field wherever it has to reach, okay, and it is through some magnetic field attracted. When it goes there, give a little bit heat so that the polymer breaks open and releases the drug there. Okay, this is a controlled drug delivery. Second example of like targeted drug delivery, like diabetic patients need to take insulin or medicines every day or periodically, whatever. Suppose there is a patch which is there in the stomach, which will release insulin as required by the body, depending on the glucose concentration in our blood. It will smartly release the insulin and it will go for 1 month or 15 days. So you have to just change it once in a while. That is called as targeted drug delivery. Okay. So controlled drug delivery, and earlier was a targeted drug delivery. So these are the new methods which are possible using nanomaterials. Glucose sensing, we have to prick, no? Diabetic people have to prick and get the blood. Suppose you are able to sense it through saliva or breathe. The gold nanoparticles are playing role there. Their plasmon resonance, the optical properties change when something gets bonded to it. And if we sense that change in the optical property, we can sense how much is the glucose present. I'm just simplifying the subject, what I'm showing on the slide. For strategic materials, again, carbon composites are playing role. They are withstanding at very high temperature with the strength and thermal performance, insulation performance. These are the best used materials where carbon composites like fibers and nanotubes and their composites with other polymers. Now, we are also working at ARCI on the steel. Now, normal steel, which is if we add some nanoparticles to it, like some oxide nanoparticles in a very small concentration, it will increase the strength of that steel at high temperature to a very high level. Okay, so these materials are very specifically required for strategic applications. For example, in the nuclear reactors, in the turbine blades, the power generators, where the supercritical, like very high temperature power generation is this generation has an efficiency is increasing because of the temperature what we are going to enhance in the generators. So materials also are to be evolved along with the concept of whatever new we are bringing. Now, our dear Sunita Williams came back. You may have heard this news on the in TV that there was one material, like the capsule which went was a white in color, which received after was burned. It withstand 1600 degrees centigrade temperature. I haven't yet researched what was that material, but it was mentioned that some grade of material was used to. So these are kind of very special materials required for various applications. Okay, we know that there is a lot nanotechnology is used in cosmetics, textiles, air cleaners. We are going to be probably required after few years. Every home will have some purifier, home purifier, so we can live and probably will go less out of home, or we will have some cartridge on our mouth. I don't know what will happen. Let's hope that this day will not, we don't have to see, and let's work for that. So nanoporous materials which will get heated, kill the bacteria, also trap the dust particles, and the clean air comes out. These are concepts for good pure air. Photochromic textiles, you forget about what I have written. We use photochromic glasses anyway. But if I tell you, even I like to do a lot of fashion. Today my sari is green. I want it tomorrow, suppose in the winter, I want it blue. So depending on the what sunlight I'm getting exposure, I want a different color or different, structure. Like it's just a fun I'm saying, but there is a lot application in the defense to have a camouflaging. Okay, depending upon the exposed light, it will change its color and then merge it in the environment so that it is not detectable easily. So photochromic textiles and paints are also again nanostructured materials. A lot of research is happening looking at the biology, what is there in the nature. Okay, there is an answer in nature for every problem. If we are stuck up somewhere in the research, we must find something in the nature, how the nature solves this problem. And biomimicking, like all our sensors, like 5 senses in our body, are so amazing. The best architect or technologist is the nature, like ultimate. So we look at that. So we try to make a skin-like structure. I'll just give one example. Our skin can detect softness, hardness, temperature, the breeze, pressure, everything. Is there any sensor available which can do all the jobs what our skin does? No. We are just trying to make something looking at what nature is doing. So this is a new branch. It's not new, but I'm saying that getting emphasized on that we can do that. Okay, so we can actually using the concepts in biology or in nature, we can check pH, heat, light, electroactive substance, mass change, everything we can do using the concepts in the nature. Now, I would just want to have a glimpse. You must know these words, which is called as materials are fine, but to make them in a device or a product, we need a good techniques. So this is the new and buzzing technique, which is called as additive manufacturing, or it is also called as 3D printing. We know printers, but now 3D printing is coming up to get whatever shape, size, design we want of whatever material we want. So there are 3D printers for polymers, for metals, for ceramics, everything. So this is extremely important and it's going to revolutionize the manufacturing. Okay. So I cannot probably. Sorry. Can I take calls? Just 2 more slides are there. Then
Probably after this.
So anyway, leave it. There are some very nice videos you can look at in the YouTube for 3D printing of various materials. Now fiction to real. So whatever we thought of fiction earlier is now real. I just want to give you one example. If I say that we can make something invisible, that was our childhood stories we used to read, right? Apply some cream and become invisible. But it's real now. Okay, these are metamaterials called as. Metamaterials are having a assembly of materials. Individually, they have certain optical properties and certain chemical physical properties, but they are organized, arranged in certain arrays, and they're put it on the surface. Now, what is that makes them invisible is their overall refractive index. Generally, when light passes from one medium to another medium, there is a refraction, right? You can see the first part of the figure. There is a bending of the light which happens. But these metamaterials actually reverse the direction of the light. Okay? And that's how, if there is an object, there are two ways how it passes. It just goes back in the direction, and it appears that it has not seen that object at all. This is a reality now, and I heard recently in the newspaper that IIT Kanpur has transferred a technology to industry to make these products for our defense. Okay, so I am so amazed about it. What all science can do. Quantum computing, you must have heard about this in the literature. Again, it's a very complex phenomenon for me to explain. Neither I'm expert in that, but I'm so amazed with this particular technology. Again, quantum materials are playing role. Quantum dots and other quantum materials are playing role to execute such a huge data processing in a fraction of a second, which will take years for normal computer. Okay. Now, as I told you in earlier slide that AI and ML are accelerating the material research, which predicting the crystal structures or properties or anything, it's becoming like unavoidable, like must part of our research now. And we must capture it. The young people will be faster to do that. It is very difficult for the seniors to do it, to capture it, but I think it's must for all of us. Then I'm just highlighting robotics, gene editing. This is revolutionizing everything right now. I want a robot at home. I'm ready to buy it, whatever cost it is there. Who will do all the jobs what I want to do it at home, isn't it? So we have quality time to do whatever we want. So I don't think it's fiction anymore. Gene editing, we are going to the root cause of the problem to remove the defective gene and replace it with a healthy gene and solve the problem. It's so amazing. Those who have somebody at home or those who have issues, they only go through this kind of trauma. How to save the person. Even if you have money, you cannot save the person, right? So these are going to be this is going to be a life in short while. Can I have 2 minutes? Okay. So I just want to give one more message because I'm a technologist. Please do not restrict your research or your science learning only for writing some papers or think about it what you're doing. So first important, any commercialization, you yourself may not do it, but somebody else will do it, okay? Or you yourself also can do it. Novelty is important anywhere, whether it's structure, composition, process, whatever. Okay, then performance. The material must perform well. The cost should be reasonable so that affordable for that particular consumer who is going to use it. Market. There should be a market for whatever you are developing. Then only it will bring the sustainability for your work, what you have done. And it should affect the economy. Okay, then only the whole effort, what we have done in our life, if we really say that we are working for the mankind or for our nation, we have to consider all these aspects from the day one of our project. This is my message to all of you. I have realized it after a long time. Nobody was there to tell me all these things. But I want to tell to people that please follow all these as much as possible so that you will see your own product in the market in your own life. And you will be so satisfied that the all effort are worth what you have done. So although I said materialistic life, we must have we should not go too much materialistic also. We should go towards the meaning is whatever we do, we should do it for a good intention, for the goodness of everybody. Then only there is a meaning to what we do. Thank you so much. Let's make our science one sustainable future. Thank you so much. I'll be happy to have questions if there are any.
Thank you, madam, for the wonderful
Yes.
talk covering all aspects, fundamentals to the latest applications using the nano materials. So now it's open for questions, probably.
Yes, please.
Natural cut, like we can go for strands and all whenever there is an issue. Like if we 3D print a heart, like can it be repaired, madam, or one time?
Yes, hard. Yes. Although the technology is not in the market right now, but there are 3D printers for biological tissues. Okay, the machines are in the market. Now, efforts are going on to print our own organs. Liver, I'm not aware about heart, but I think it is possible. In our organization, we are making stents which are put in the body by 3D printing. By the way, I wish to tell you that. But about organs, I don't find now any subject as a fiction. It can become reality. That's what is my belief right now. Thank you.
The output of the printer, can it be repaired once again, madam? Like reusable?
Good thought. We must think about it. I can't answer this. You can think, like, I'm equally of the same knowledge of you, what you have, the curiosity. It triggered something in my mind. Oh, is it possible? Thank you.
Maybe I can add something. Repair means what sense?
Once our heart has been generated after birth, for our natural heart, sir, we can do first operation, and then once fixing it, we can operate it on for the second time and also on the third time. But 3D printer output being a single time output, can we redo some?
Probably repair not required. We will replace it one more time. Why not? Fresh, brand new.
Basically, the 3D printing most of the time, as of now, is not a matured level of printing for
Organs, yeah.
organs, right? It's only for metal. Suppose you want to have a Taj Mahal model, then have a Taj Mahal with different layers. So to that extent, if one of the pillar gone wrong in Taj Mahal, then you have to rebuild it, melt the material, do it.
Thanks for answering my question.
Thank you, sir.
Sorry. Yeah.
Any other question? Okay.
I just want to ask,
Yes.
in gene editing, like at what stage nanoparticles are used?
Well, I'm just telling you, gene editing is not nanoparticles there. It is like a biotechnology technique there. So whatever gene you are removing by cutting, CRISPR-Cas9 method you may have heard about, right? It's to cut that and put it. Now, how will you build that? That's a very small part of the gene you have to replace it. Can I say that as a nanotechnology? Isn't it? To build that particular gene to be replaced is a very small part. And that also requires equally same precision at the nanometer. So it's not nanoparticle, but definitely at nanoscale. Always, it's not particles. Okay? Nano means some feature in the nano.
Scale. Can I add something to that?
Sure, please, ma'am.
Regarding gene. So basically that is meant for removing the genetic diseases. Okay. So should not carry forward to the next generations. So the mutation and manipulation will be done.
Yes.
Genetic engineering.
Yes. Perfect.
Sorry.
Perfect.
Ma'am, will pharmaceutical companies allow, ma'am, if you through nanotechnology, your same stomach, you can give chips and all. But these pharmaceutical companies, they'll be just relying on medicines only.
No. This is happening. It's in the practice.
Doctors, once, if we say, like my mother-in-law is sugar patient, ma'am, at home only I'm saying, we just say add methi or bitter gourd daily means the doctor will say, no, it's not good. You have to take medicine and insulin that.
From actual product to come to our life, there is a way, like it takes time. It will come. To become it is very common in our life. There is a journey for the technology to reach to the every person, right? So it has to be proven. We also will not accept just like that, right? Unless we study it properly, right? How many clinical trials are done, and high doctors will suggest only when it becomes affordable, common, clinically proved, everything. But they come to the market only after the approvals. They don't come just like that. And pharmaceutical companies will jump on that. I'm telling you.
Immediately without any delay.
Yes, please.
Ma'am, can the AI and ML predict the success rate of the gene editing? If yes, to what extent?
See, I'm not expert in AI ML. I'm giving you overview of what is happening in the research field right now. Okay, but I can tell you, I know how it works. Okay, and we are applying it in one of the projects. So I have some information about it. Definitely, it will happen. And that is why they are important, right? They are able to make predictions. And of course, see any computational tool, how AI becomes matured, it is thinking like a brain now, correct? It will improve further and further. So the success rate will go on increasing only with time.
Thank you, ma'am.
Okay, that's all. Okay then.
Anybody?
Thank you so much for your patient hearing. And I'm very glad to connect with you all. And thank you so much to the organizers for inviting me here. It was a great opportunity for me to be here. It's my honor. Thank you so much.
Thank you, madam.
Thank you so much, madam. It's really a thought-provoking lecture, and you inspire our young minds to to think again for the sustainable future. Thank you very much. At the outset, I thank you for accepting our invitation and delivered a keynote lecture on this plenary session. I now request Koteshwar Rao to give formal vote of thanks. Before that, is there anything for you to?
No, just to summarize, I think.
I now request Professor Madhukar Garu to summarize the session. Then we'll go for the vote of thanks.
Okay. Yeah. Thank you, madam, for the wonderful talk covering all aspects of nanoscience and the latest development in science and technology. So, madam started with remembering the contributions made by an eminent Indian scientist, Dr. Jagdish Chandra Bose. We all still remember that. Yeah, I think he's the first person to say plants also have life, right?
Yes.
So, we hardly remember our Indian scientists. That is the problem with us, including me. I cannot just blame you, right? So he founded the Bose Institute. I think some of the physics students, background students might be knowing quantum mechanics and Einstein, right? But there is some theoretical models developed by the Bose. Okay, there is a Bose Einstein. I visited one lab in Colorado, one physics department. There in front of the board, they wrote this department has 5 Nobel laureates only. So in future, we would like to see, of course, we are, as Vice Chancellor said, we will not be around, but we will see from sky that Indian universities will also have similar boards. There, one of the lab, that is all depends on you. So that is a responsibility on your shoulder. Inside the department, they mentioned the clear contributions made by the Bose and how Bose is great. Okay, so we should also remember him. So there are like many things. So Madam started explaining the things like AI and of course the attachment to our mobile phones. So the technology, to what extent? Of course, we know that the physics simplify, we cannot stretch beyond limits, right? So anything has a limitations. So using mobile phones or anything, using your brain is also has a limitation to think. So these are all some, enough secrets by her message that we should follow that. So also, Madam has highlighted the life cycle of development materials. It's not so simple. So starting from thinking at what material you need to be used, what purpose you are to use, and how to commercialize it. So it is a full life cycle, is a tedious job. So we are fortunate to have a madam with us, having that knowledge and transfer to us. So there are many examples madam shared, and of course the questions are also related to that. So with that note, I thank you, madam, for all wonderful talk and enlightening.
Thank you, sir, for chairing the session. Though it is a very short notice. And before the vote of thanks, I now request Dr. Sridevi, Professor of Mathematics, join us in felicitating our keynote speaker today, Dr. Neha. Again, green. Oh, nice. Matching. Please.
Did I tell you?
Please come.
Thank you.
So,
Thank you, madam.
this is overwhelming. It is my duty and responsibility to talk. So, nothing much I do. But it's yeah, thank you so much.
It's beautiful.
Sensible, Madam.
Respected dignitaries on the dais, faculty members, participants, research scholars, students, and ladies and gentlemen, very good afternoon to all. It is honor to express vote of thanks in this plenary session 1. First of all, we thank Dr. Neha Hebelkar Madam for accepting our invitation and delivering an elaborative and a very informative lecture. And also thank Professor K. Madhukar Garu for accepting to act as a chair for this session. And thank you very much, Madam, Dean Faculty of Science, Professor Chakrapani Madam. And very thank you all of you. Thank you.
Anush, say lunch. We will break for the lunch.
Please join the lunch at the first floor. Okay, thank you.
All of you, I request all of you to join for lunch, and after the lunch,